Procedural versus object-oriented programming. Procedural versus object-oriented programming. Your simple introductory programs are procedural. Here you are simply using token types supplied by the programming interpreter and available libraries. So as long as all you are doing, you are just using token types supplied by the programming environment and available libraries. Statements such as code fragments here allow you to use these statements allow you to use types beyond the basic elements of the core Python. What you do, for instance, you see this statement which I copied, but I didn't copy in full. Say, when you say from Python, from my matplotlib underscore then import and so on, import, or from matplotlib import pyplots. When you have those statements are extending the basis of the tokens that you can use, that you can give meaning to beyond the ones provided directly by the Python environment. So the import statement, the from and import statements make your program extend beyond what it's just like when you buy anything. You can buy a car and buy accessories to the car that was not envisaged by the person who made the car. So, or you buy a phone and you go to buy a cover jacket for it. You go and buy some other accessories. So the way you accessorize your Python language is by importing other people's work. When you import other people's work using statements like this, there are some things that will now make sense to Python. When these statements are removed, those things will not make sense. Just like when you accessorize your phone, there are things that your phone will not. For instance, suppose you add an extra memory chip to your phone, then you can store more than what you could have stored in your original phone, and so many other things. Suppose you put a USB or a Bluetooth a headset, then there are so many things you can then do. Some of them can even be more expensive than your phone itself. So also can some of the things that you can import into your language, into your software, into your program, so also can they even be bigger than what is provided for you in the language itself. But you are looking at these examples that allow you to bring those things into play. So what we are saying here is that everything is procedural as long as you are simply using core Python and library types directly. So when all you have done is that you are just programming in the traditional way and using the facilities provided by Python, or in addition add libraries from third parties which you can import the way we have done here. When you are doing that, you are doing what is called procedural programming, just following the normal control structure that you have been taught in the compound statement that were taught early on. So that is what we mean by procedural programming, just program simply. Object-oriented programming. But Python itself is object-oriented. Now, you need to know how to do object-oriented programming, even if you are not going to write object-oriented programs, because the libraries of other people you are going to import will be written in an object-oriented way. So even if you are not going to do object-oriented programming yourself, having the knowledge of how object-oriented programming is organized helps you to be able to program and use other people's code much more efficiently, because since you know how their program is working, you can use them more efficiently. So object-oriented programming means that you are allowed to create new types yourself, and that Python allows your created types to function just like those created in the language or in your imported libraries. So once you begin to create new types, and the keyword that helps you to create new types is class. Once you begin to use the class keyword, you are already moving into the realms of object-oriented programming. Once you begin to add your own types into the program, you are already doing object-oriented programming. The class keyword and its structural elements take you into object-oriented programming and type making. Object-oriented programming is primarily type making and its consequences. Once you begin to make types, you get into what we call abstract data typing. And then, because the types might be related to each other, there may be a class hierarchy, and that gives you what the idea of what we call inheritance is rooted in the class hierarchy. And polymorphic programming is the result of that class hierarchy and inheritance. The difference between types you are given, the types you are given, and the ones you create is not in what they can do. The difference only comes from how they are created. Some types were created and they are fundamental. Before I move on, I want to be sure that the class is awake. Please go to the chat room and remind me what the fundamental types you know in Python are. I want to be sure that this class is awake. Please tell me what fundamental types you are familiar with in Python. Chat room, chat room, chat room. List. Okay. What other fundamental type? Tuple, integer, dictionary, tuples, dict. Loop is not a type. Somebody said loop is a type. That is Akeem, Sonny. You are wrong. You have missed that. That is not a type. String is a type. Dict is a type. Boolean, dict, integer, Boolean, float, string, float, and so on. Tobechuku, I hope you know that float is not spelled the way you have spelled it. No capitalization. Ayomiku, list is a type. String is a type. Float is a type. Okay, so good. So you know what I'm talking about. Your integer is a type, but it's typed int. Okay, so you string, float, Boolean. Okay, number is not a type. Alib, Sunny, number is not a type. Number is not a type. Integer is a type, but number is not a type. Okay, so I think most of you have an idea. So when you are limiting yourself to those fundamental types or the types that you can get from libraries that you import, once you limit yourself to that, you are not doing object-oriented programming. But once you begin to create your own types using the class keyword and associated structural keywords, then you are beginning to do object-oriented programming. So, and the class keyword is the primary way in Python to create new types. The word class and type are used interchangeably. Usually, the types that are created by the computer are called types. The one that you create yourself are called class. But essentially, the words are interchangeable. They are essentially the same. There are three pillars of object-oriented programming. And remember, the reason why we are teaching object-oriented programming is not even so that you might do object-oriented programming. The primary reason is that you need to understand object-oriented programming in order to function, even if you are doing only procedural programming, even if you will never create a new type, because as long as you are using other people's types, in fact, the types that are fundamental, I will show you with an example today, how deeply object-oriented, even some of the types that you know are, how deeply object-oriented they are. So it is important for you to understand the theory of object-oriented programming, apply it, and use it. That is, the three pillars are abstract data typing. That is when you create a type using the class keyword that has data members, which is the internal state of the object created, and methods that can access them. Those are the essential things. There are many other things, but The essential thing is that there are data members and there are methods. When you do that, you are encapsulating because you are mixing the data and the methods that access them together in a type or in a class. Then inheritance is the ability to create new types, new classes based on an existing class that you can further improve on. And the only code you write is the code that improves on. So if there is any mistake, the mistake does not come from the already working class. The mistake is localized in the part of the program that inherits. Therefore, it is easy for you to debug your program because you don't just go everywhere. If you write only procedural programming, when you have an error, you are going to be running like a chicken without a head. You know how a chicken without a head runs. It starts running, then you ask yourself, where is it going? The head has already been removed and it's still running. So you don't need to do that. The inheritance is actually the way, it is the primary way of extensibility of object-oriented programming languages. And it is what makes object-oriented programming superior to procedural programming. And that's why virtually every software, whether it's your word processor or your spreadsheet or your whatever you are doing, the people who wrote them probably wrote them in an object-oriented programming fashion. That's why newer versions can come up, because anytime they want to do more, they just simply inherit what was there before and add only the new things. And because of that, it is object-oriented programming that made it possible for the energy you have in the software industry. So object-oriented programming may look cumbersome to start, may look harder to start. In fact, it is a much simpler way to handle programming. After you have learned the basic rudiments of it, you just find yourself doing some things really well. The third step is polymorphic behavior based on class hierarchy. We will not dwell too deeply on that, but you will see how it works. Even in the simplest class hierarchy, like the student class that we have created, we will show, but we like to work with examples rather than theory, talk. It is when you have an example, the explanation is much easier to effect. Fundamental types. Some people did not understand what fundamental types are. Fundamental types can be scalar and can be a collection. You begin with fundamental types such as int, float, bool, string, and so on, that are scalar in the sense that they create a single data object. So if you say int, you are creating just one number. If you say float, you are creating just one number. If you say bool, you are creating one Boolean or logical value. If you say string, you are creating one concatenated string, and so on. Because of that, we can call those fundamental types scalar values. They are scalar values because they only have one simple value of data that they have. There can be several methods that you can use. For instance, you can invert an integer, you can square an integer, that's another method. You can do many things with that, but you are still working with that single data. There are also collection classes. When I was asking you to tell me fundamental types, I was disappointed. I was expecting you to know that, at least to tell me that there are two kinds of fundamental types, the scalar types and the collection types. The collection types are lists, tuple, set, dict. Those are the ones that are in the core language. There are some others in the extended language. You can have some more complicated lists and some libraries, some trees, and so many other things. But in the raw core-based language, there are just a few scalar types and a few collection types. In the core language, these are collection of scalar types or scalar mixed with collections. And this thing can become really complicated. So you can now start, because when you say list, a list can contain integers. A tuple can contain floats. A bool you can have a set of bools, and you can have a dictionary that contains strings both in the key and in the data storage. But there's nothing stopping you from having a list of sets. You can have a list of sets, and you can have a dictionary that contains keys to lists. So these things can become really, really complicated. But they follow simple logic. Once you understand how they work, do not start with the hard part first. Understand the simplest things, and you'll find out the hard part will follow through logic. These types, whether scalar, whether collection, are fundamental because the most basic Python installation contains all of them. They are fundamental. Why? Not because they are superior, but just because the most basic Python installation contains them. All their keywords are already recognizable to Python from the outset. Whereas there are some keywords that can come later. For instance, take a keyword like PLT. PLT can become a word that Python can recognize, but it will only happen after you have had a statement like from matplotlib import pyplot as PLT. It's only from this point on that PLT becomes a recognizable word in Python. Or that up till that time, if you use it, it doesn't know what you're talking about. A deeper understanding of a simple code. What I'm going to do at this point, let me see how much time I have. What I'm going to do at this point, wow, it's already 1:50. Now I think I will give you 20 minutes break. And at 2:10, you come back at 2:10, I'm going to take you through a very simple code that we have seen before. And you will now use the eyes, your renewed eyes, as a result of your knowledge of the basics of object-oriented programming, to look at a very, very simple code. And you will see that new knowledge will come out of it as a result of your new knowledge of object-oriented programming language. So let us take a break of 20 minutes. And when we return, we're going to be looking at a programmer's code. So see you later. I said I'm going to look at a very simple example. A very simple example is what we did when we did the Venn diagram last term. We imported some ability to create Venn circles and ability to plot and show those plots in some files, in some imported libraries. One of them is called pyplot, and which we are importing as PLT. It's an object-oriented thing. So when we say when we ask it to show the plot and so many of those things. But let us see the preambles. The first 3 lines are clear. These first 3 lines are just telling us that we are importing other facilities, which turns it into strings of A, of B, of C, and so on separately. And we did that and we assigned that that gives us a list. We have 3 lists here, and we can take those lists and try to turn them to sets, and we turn those things to sets. We turn them to sets using the constructor of the set here. We turn cos1 to a set, cos2 to another set, cos3 to another set. And we can now take a Venn diagram of those 3 sets, which will show us the intersection and all those things. And so on and so forth. We can move on. Let us just take a look at this, and you'll see how much we learn because we now know about object-oriented programming. Because we now know about object-oriented programming, we're able to learn more about what we are doing here. So as you learn more theory, you will even understand what you were doing before in a deeper sense. But if you are doing nothing before, understanding more theory does not benefit you. So it is not overemphasized. You just got to walk through programming code. It is instructive for us to go through this thing. And I'm going to ask you to do some things, the kind of questions that I can ask you in an exam on this code. Like I told you, you are not going to write a theory exam. You are going to have your code, and you are going to do more coding on it, on your own computer. That's what you are going to do for an exam. So So let us just debug this program. I have created two breakpoints, but we can move through it step by step for the first breakpoint. Now it is at breakpoint 1, which is line 4. So if you look on this side, you are seeing that the locals here are PLT because PLT was defined from the importation here. So it knows that it's a module called PLT. And you can look at that PLT has a lot of things that you can look at there. Globals, there are not much to do. But let us see if we run through that line 4. Once we run through that line 4, you can see here, course 1 is defined now as a list. It's now a list. You can see the contents of the list now are, if you want to look at the contents of the list, that is it. That's the contents of the list, course 1, which is caused by receiving the result of this method call. There is a method, this means that there is a method in the string class because this is a string. This is string, even though a string is a fundamental thing, but it also has methods. And the method here is split. But that method split creates a list of the splitted members of that string. So it created that list. Similarly, by the time I execute the next statement, if I execute the next statement, you can see that course 2 has been similarly created, and it's a list. Next, you see that course 3 has been created here, and it's also a list. So because we have these 3 lists, we can now do a Venn diagram of the 3 of them by turning each one of them to sets. We turn each one into sets. You can see that this constructor call turns course 1, course 2, and course 3 into sets and does a Venn diagram of the 3 of them. And then when it does the Venn diagram, if I do another run, it has let's see whether there is something to show now. Okay, so let us see. You can see this is the Venn diagram now that we can see here. So this is the Venn diagram of the 3 of course 1, course 2, and course 3. This is the 3 Venn diagrams, which will show you the intersection of, in fact, the elements now that are intersecting all the 3 together. So there are 3 things that all of them have together. Now, let us see how much you remember from your set theory. Can you tell me which are these 3? Can I go to the chat room and tell me which these 3 that we are seeing here, what are the elements that are shared by course 1, course 2, and course 3? Let's see whether you can pick those out. I can see 1. Find the 3. There are 3 things that are contained in all the sets. Go to the chat room and tell me if you can see if you can pick the 3. Or if you can pick. Let me see whether some people have got it. Somebody says EHB. E is here, E is here, E is here, H is here, H is here, H is here. EHB is not correct because B is not in the third, it's not in course 3. EHK. K. Yes, the person who said EHK. So I mean, this is nothing, this is very simple. But you see, isn't it interesting that you can use the computer to do this? Is it trivial? Even though you could do this before, but that you can now use the computer to achieve the same thing that you could do before, that is your first baby step in learning how to program. That's it. Now, I want us to now take another look at this. What I want you to do now is to write a fragment of code. I want this line 4, I want you to do it in 2 steps. The first step is to assign this string to an identifier. Assign this string to an identifier first. And it is that identifier you should split. So I want to see your code now. I'm going to the chat room. I'm waiting for your code. You assign the string to an identifier. And instead of splitting the string, you are splitting the identifier, which will give you the same result. I want you to do that. I will go to wait for you in the chat room to see how many people can do that. Did you get the question? The question is that you can see this string is being split directly. I want you to split it indirectly by, first of all, assign this to an identifier, and then it is only when you now split that identifier that you assign the result to cos 1. You are, instead of a single line of code in line 4, you are now going to have 2 lines of code. Is the question clear? Or do you have a problem with the question I'm asking? I'm still trying to find somebody who has gotten it right. Michael, you are almost getting it right, but you didn't put quotes on your identifier, so on your string. So that is not, you are going to get an error in that statement you have made. Favor, you are almost right, but you remember that an identifier's name cannot have a space. So that is wrong, because an identifier's name cannot have a space. Ejiro, I don't know what you are saying. It's an alphabet identifier. When did you assign something to it? Ibrahim Gani, you are almost right. Your first statement is correct, where you assign A, B, C, D, E, F to cos 1. But the second statement is not wrong, because same split is a method. It has to have its parentheses, whether that parenthesis is containing anything or not. Tobe Chuku, the same thing, your same error you are making here. Your split doesn't have Ademola Ikushedu is the person who seemed to have gotten it right, but I still don't like his code. I don't like your code. I will tell you why later on. Ejiro. So Ejiro, you are almost right. You are almost right. You see, alphabet is equal to A, B, C, D, E, F. That is correct. You are cos 1 is equal to A, B, C, D, F is correct. Or alphabet is equal to A, B. But the then you put there is wrong. That's not a programming language. And then the splitting, you did not assign the result of the splitting to anything. So unless split is in place, you need to give the result to another identifier. So you didn't do that. So you can see how much I can ask you if you have your code to yourself. So you thinking that you will have to, you are, I hope through this lecture and through what we are doing now, you're able to see that I can ask you all sorts of questions within your code. And let me just see here. Ajayi looks correct. Sorry, Eric Folami is correct. So A, B, C, D, E, F, I, J, K is Ajayi. Then cos 1, good. So that's the way you can do it. Ademola Ikushedo, I think you are now correct, though I still do not like your code, because on one line you are using cos 1 as a string identifier. In the second line, you are using cos 1 as a list identifier. I don't like that. I don't see why you cannot use another identifier in the first line. That is the same error. That is the same. It may work, but I don't like it. That is, Ali is doing the same thing. Michael is wrong because he's just assigning cos to A, B, C, D, E, F, I, J, K, where that is not a string, because if it was to be a string, it must be in quotes. Ejiro, Oroga, alphabet is this. Yes, the then there is wrong. Ejiro, I keep telling you, the then there is not part of the code. You are going to get an error there. That shows you are not programming. Ademola Ikushedo, I'm still not happy with the code, because you are using cos 1 as a string identifier, and you are using cos 1 as a string identifier and as a list identifier on the same line. I don't like that. It may work in Python, but you get error in some other programming languages. So it is not a good code. Okeze, you did not, you are using the same identifier. You should have used two different identifiers. Similarly, Freeman or Takonwa is still doing the same, making the same error. He's using the same identifier as a string identifier as a list, because what receives the result of the split is a list. And so on one line, course one is both a list and a string, which is bad programming. Similarly, Michael, you are still making that same error. Onye Consola, the same error. Okay, Favor Taiwo is the first person, I think, that has done it, that has answered that question correctly. Ejiro, you are still in error. You are still using then. I wonder why you just repeating yourself, despite the corrections I'm giving you. Ejiro, are you awake or sleeping? Tobe is basically okay now. Tobe Chuku, you are basically okay now. Daniel Ajayi, you have not answered the question. Read one, yes. Read one, you are essentially okay right now. Oladapo Tobade, that's okay right now. Okay. God's type, you are even gone to the extra step of, you have gone through the extra step of printing the results. That is what I want. I want you to take my code fragment, understand it, run it, and do other things with it. So God's type, you are listening, that's good. Even though you did it late, but it's okay. Michael is now doing it right. I'm not saying the other code will not work. At least you are still in the error I have been correcting. Please wake up. Okay, Ejiro, you are right now. You are doing okay now. Fawaz, yes, that's good. Okay, good. Good, God's time, good. Good.